Let's talk about primitive data types. So the word primitive, when it comes to computer science, at least with Java, means that it cannot be broken down into anything more simpler. So it cannot be simplified. So if I'm working in BlueJ and I type a primitive data type such as int, you'll see that it shows up in red. And you'll notice that the primitive data types are always lowercase, where an object such as string, which might seem like a primitive data type, but it actually can be broken down into characters. So it is not a primitive data type. Those are capitalized. And we can have a lot of data types that are not primitive, such as color. We have some kind of color class, or we could have, the random class. Those they're objects, but they can also be considered data types. So the integer, or int, is the first and probably the most important data type that we deal with. And it is for whole numbers. That means that we can have 1, 2, 3, 4, 5, 6. We can even have negative numbers like -1, -2, -3, and so on. But we cannot have fractions. So we can't have 1.5 or 7.823. The integer does not allow for any fractions, and the integer is usually the data type that's used the most. It is a 32-bit storage in RAM. That gives us a huge range of numbers that we can use. And so, we could track all the people on Earth with this thing. So, if I want to say, okay, how many people are on Earth? Total people on Earth. And the integer would work just fine for that. If I wanted to track something much bigger, like the grains of sand in my pocket, well, we could use something that it does quite a bit more. It's also positive and negative, and that's called the long. So we could say total grains of sand, and the long is probably going to be plenty enough for that. We cannot track all of the grains of sand on Earth, but maybe just on one beach, I guess. And so we got the long. Well, what does long mean? Long means 64 bits in RAM. And long has its little friend. Its little friend is called short. Short is one of those data types that, well, I can't remember a single time when I've ever used it. But it's there. And it's good for numbers between -32,000 and +32,000. And so that might be good for tracking all of the students in our high school, as long as we just do 1 year, I don't know, or maybe students in college. So total students in our college. And then if we really want a small integer, we can use the byte. So the byte is 8 bits, and it gives us 256 numbers. The smallest one is a -127. The highest one is +128, and then the 256th number is 0. So this is something that we can use. Well, if I'm going to track the number of people in my class, total students in class, I have about 24 students in most of my classes. I don't ever have a negative number, but this is something that I could use for that. Now, the question is, which one are we going to use and why? And it might seem obvious. You might say, okay, well, let's figure out which one we need, and then make sure that we don't use something that's bigger than that. So if we only need to track the number of students in our class, let's don't use integers. That's way too much space. It's going to use up too much RAM. It's going to use up too much hard drive space. It's going to take a lot more time to process than the byte. But in reality, if we're concerned about performance, we're not even going to choose Java as a language. We're probably going to choose C# or something like that. But if there is a case where we're concerned about performance of Java, we might start choosing these other data types. But generally, always, we're just going to stick to one type of data type when it comes to integers, and that's int. By sticking to int, it makes it easier to program. And it also makes us work easier to collaboratively program. So I can write a program, I'm just using ints, you're writing a program, you're just using ints. And then when we start working together, we're all using the same data type, we never have to convert, and we never have to make assumptions. And hey, why is this not working? Oh, it's because you're using the short, not the integer. So almost always, these other data types are not used unless we're just really bent for performance. And then again, if we're really that serious about performance, we'll probably use another language. So these are the 4 data types that we use for integers, and there are 4 more primitive data types that we haven't talked about yet. And let's talk about the 2 data types that are good for fractions. And so one of them is the float. So a float, you might think that we could track how much money we're using, or how much money we have in bank. If we have a bank program, we could use float, but actually float is not very good for that. And what I tell my students is that shit floats. And that's a way of remembering, don't use float because it's shitty. Sorry to cuss, I usually don't. That's the only time you'll hear me cuss. But don't use float, it's not much good for anything. It is 32 bits. And it will allow you to track fractions, such as weight. So how much does the person weigh? Well, this float would be fine for tracking how much they weigh. For scientific calculations, however, you might want to use the double. So the double is the second type, and it's much more precise. And once we start averaging and multiplying fractions and doing a lot of mathematical stuff on fractions, then the double comes in handy. So I'm just going to have a double called average. And generally, I just stick to using the double. The double is the only thing I use. It's the only thing I tell my employees to use. So I've shown you 6 different primitive data types. I only use 2 of them. But there's a few more that I do use. One is the Boolean, and that's good for something that's true or false, and usually it's displayed in the form of a question. So like in a video game, if you're trying to figure out if the player is alive, you might say is alive. And it's kind of like a question. Or has sword. Or is open if it's a door, if you're checking to see if the door is open or not. So Booleans, they're going to be equal to either true or false. And we use them all the time. There's another one that I like to stay away from, but that's the Char. And that's actually short for character. I spelled, but of course we don't spell it long ways. For some reason in Java they decided to spell it Boolean. In C# they just do bool, but they did abbreviate character so it looks like char. Anyways, when we're talking about a character, we're talking about a symbol, and there's lots of ways that I can do a symbol. If I hold the Alt down, and while I'm holding it down I type in 157, I get the yen sign, and then I release on the Alt. So there's a lot of different characters that we can type in. And with Java, we are talking about Unicode. So we're talking about 65,000 different characters that we can type in here that represent every character used in the human species. So that's quite a lot. But it's just a single character. And so here I'm doing favorite letter. Now if we want to assign it a value, we use half quotes. So if I want to say my favorite letter is the letter Z, capitalized. Now notice that this is a symbol. I could also say 5, but when I'm saying 5, it's the symbol 5, not the numerical value 5. So there's a big difference there. I can't add and subtract this symbol 5. It's just the character. Anyways, we use those half quotes instead of full quotation marks. So those are all of my primitive data types. And I will talk about string because we use it all the time. It is not a primitive, it's capitalized. it's an object and it's got methods, and we can do a lot of tricks with it that we can't do with the primitive types. But usually when we declare that, we can say our favorite saying. Yay, I don't know. The string is made up of a bunch of characters, an array of characters. All right, that's it for primitive data types.